In the vast darkness of space, there are objects so powerful, so strange, and so extreme, they warp reality itself. Light vanishes, time distorts. And once you cross the edge, there's no turning back. These are black holes. And what you're about to learn might just change how you see the universe forever. Let's start with the basics, and then go deep. A black hole is not an object in the traditional sense. It's a region of space where gravity has become so intense that nothing, not even light, can escape it. That's why we call it a black hole. You can't see what's inside. Light doesn't bounce off. It just disappears. Now, what causes that much gravity? Mass. An enormous amount of mass crushed into an incredibly small space. At the very center of a black hole is something called a singularity, a point where the laws of physics, as we understand them, collapse. A place where density is infinite, space and time cease to behave normally, and reality itself breaks. Surrounding this singularity is the event horizon, an invisible boundary. Once anything crosses this line, it can never escape, not even light. That's the point of no return. You might imagine a black hole as a kind of cosmic drain, but it's much weirder than that. It's a place where our equations stop working. Einstein's general relativity and quantum mechanics both break down at the singularity. So how do these monsters of the universe form? The most common way is through the death of massive stars. A star lives by burning nuclear fuel in its core, pushing outward against gravity. But when it runs out of fuel, gravity wins. The star collapses inward. If it's massive enough, at least 20 times the mass of our sun, it undergoes a supernova explosion, ejecting its outer layers. What's left behind collapses into a neutron star, or if it's dense enough, a black hole. But not all black holes are created equally. There are different types. First, stellar black holes. These are the ones formed by dying stars. They usually have between 5 to 100 solar masses. Second, supermassive black holes. These are the giants, found at the center of nearly every large galaxy, including our own Milky Way. They contain millions or even billions of solar masses. Scientists still aren't entirely sure how these formed. Did they grow from smaller black holes? Or were they born directly after the Big Bang? Third, intermediate black holes. These are the missing link. Not too big, not too small. We've only recently started to find evidence of them in dense star clusters. They're elusive. And finally, primordial black holes. These are hypothetical black holes that might have formed right after the Big Bang from density fluctuations in the early universe. If they exist, they could help explain dark matter. But so far, there's no direct evidence. Let's clear something up. Black holes are not cosmic vacuum cleaners. You often hear people say things like, if there were a black hole near us, it would suck in the Earth. That's not how they work. Black holes only pull objects in if they get too close. If the sun suddenly turned into a black hole, but kept its mass, the Earth would keep orbiting it just like it does now. We just wouldn't have sunlight. We wouldn't get sucked in. Gravity depends on distance. Stay far enough away, and a black hole behaves just like any other object with mass. But get too close, and things get weird. Let's say, just for the sake of science fiction, or maybe science fact, you fall into a black hole. First, there's the tidal force. Gravity pulling on different parts of your body at different strengths. Your feet might be thousands of kilometers closer to the singularity than your head. The result? You get stretched, spaghettified, as scientists say. For a stellar mass black hole, this happens outside the event horizon. You die before crossing it. But for a supermassive black hole, like the one at the center of our galaxy, the event horizon is huge. You might pass through it without noticing anything at all. But once inside, your fate is sealed. You'd eventually reach the singularity, where current physics can't even describe what happens. Some scientists believe all information about you, your atoms, your quantum state, is destroyed. Others think it's somehow stored on the surface of the event horizon. This is called the black hole information paradox, and it's one of the biggest unsolved mysteries in physics. Until recently, black holes were theoretical, but now we have real observational evidence. In 2015, the LIGO Observatory detected ripples in space-time caused by two black holes merging. This was the first direct detection of gravitational waves, and indirect evidence of black holes colliding. Then, in 2019, scientists captured the shadow of a black hole in the galaxy M87 using the Event Horizon Telescope. This global network of radio telescopes acted like a planet-sized camera. What we saw wasn't the black hole itself, but the silhouette of its event horizon against glowing gas and light. This is where things really get strange. Could black holes be wormholes? Some theories suggest black holes might connect different points in space, or even different universes, through structures called Einstein-Rosen bridges. It's theoretical, but still under study. Is the universe inside a black hole? A bold idea in cosmology suggests that our entire universe might be the inside of a black hole in another universe. This is speculative, but, surprisingly consistent with some models of space-time geometry. Do black holes destroy information? Quantum mechanics says information can't be destroyed, but general relativity suggests black holes erase it. Reconciling this contradiction could lead to a deeper theory of everything, a unification of gravity and quantum physics. Yes, according to Stephen Hawking, black holes aren't entirely black. They emit radiation, now called Hawking radiation, due to quantum effects near the event horizon. Over trillions of years, this radiation would cause a black hole to shrink and eventually evaporate. For stellar black holes, this would take far longer than the current age of the universe. But it means even black holes aren't eternal. Black holes aren't just sci-fi nightmares. They're crucial to our understanding of physics. They test the limits of Einstein's theories. They might hold the key to quantum gravity. They shape galaxies, and they continue to surprise us. They're not just destructive. They're creators of mystery, engines of transformation, and possibly the most fascinating phenomenon in all of science. In a universe full of questions, black holes may be the biggest of them all. They are the edge of science, the ultimate mystery, and maybe, just maybe, by understanding black holes, we'll finally understand ourselves, our place in the cosmos, and the true nature of reality.